What is going on, guys? We are out here working on an old Rheem, and that's a 1997. This is one of those customers that doesn't want to take care of anything. They let the weeds grow up around everything. They want to do a checkup like every 5 or 6 years, and then they expect you to come out here and work wonders and shit blunders on this equipment. And it is what it is, so don't get on me because this thing's a mess. You know, these are not units that are having regular checkups done. And I hope you guys can hear me okay over the fan. I don't know if you're going to be able to see this that great because of the angle of the sun and everything, but I thought I would just do a little quick video on this old Rheem defrost system here, in case any of you new guys are having some trouble trying to understand this or figure it out. You know, the one thing we always have to keep in mind with Rheem equipment, we've got to get our mindset going backward because they energize the reversing valve in heat. So right now I'm running in heat mode and that reversing valve is energized right now, whereas most other equipment energizes in AC mode. So we do have to think a little bit backward. And then the thing that is somewhat confusing is here, instead of just a defrost board like everybody else, we have a combination of a defrost board and a universal 9340 relay, just an old brown white Rogers that's doing all the switching for us. So of course in here, this is a little time delay. We've got our old beat up contactor there, but nobody wants to replace any parts. And we've got a 30+5 capacitor. So over here on our defrost board, if we can see right up there at the top, I'm going to cast a shadow on this. This is going to be really hard to do. But you see up along the top up here, we have our sensor and our hold, and our 24 volts are common in and out. So basically what's going on here in these systems, everything brown is a common. So this over here is going to be the common side of the contactor. Right here is the common coming in from the thermostat wire, and then this side of the relay over here is our common, and the yellow is 24 volts. So if we were out here on a warm enough day to where our defrost sensor wasn't closed, what we would do to jump this, because our defrost sensor is this larger diameter blue wire right here, that fat blue wire, it's under that wire nut with all those other commons. So that's another thing that's different on the Rheem systems. Most systems send 24 volts down through the defrost sensor and back up to the board when it closes. This one is sending common. So if we wanted to jump this, we would carefully take off that wire nut, keep all those commons twisted together, and we would put our jumper from there over to this large blue wire here, because that's the other side of our sensor. If you can see, it says sensor up there, and that's going to be our termination point. After that sensor is closed, it's going to send common back up to the board to activate the defrost. So we have our common out that's going over to our relay, and then what's going to happen is we have our yellow wire, that's the hold, and that defrost board will initiate and send that 24 over to this relay to power it. Okay, so then what do we have going on this relay? The first thing we have to ask ourselves is, what 3 things happen during defrost? So let's think about that, guys. Whenever you go into defrost, 3 things have to happen. What is it? We have to shift the reversing valve. In this case, we're going to de-energize. And then we also have to turn off the outdoor fan to allow the coil to thaw faster. And then we also have to send 24 volts through a wire back to our electric heaters at the indoor unit, so we can offset that cold air during the defrost cycle. We got to turn those electric heaters on. That's very important. So the way Rheem is accomplishing this right now on these relays. You've got a normally open set of contacts right here and over to this corner, which there is nothing over here. There's not even a terminal there. Okay, so that would be our normally open, and then we have another set of normally open right here in the middle with the blue wire and the purple wire, and that's going to be the wire that goes back to the electric heat. So then our normally closed contacts are always right here in the middle. So right now we have power, 120 volts, going to the fan motor here because this is closed, so our fan is on. And then right down here we have our 24 volts sitting there on that blue wire that is now energizing this fat black wire that's going down to the reversing valve. So it is energized right now. Alright, so let's think about what happens when we energize the coil on this relay. All that's going to reverse. Everything that is normally closed is going to open, and then our normally open is going to close. So we're going to accomplish our three things that we need. We're going to open the energized reversing valve right here. Our reversing valve will de-energize and go into AC. We're going to open this set of contacts here, which will turn off our fan, and then we're going to close that blue wire over to the purple and send power to our electric heat. Alright, so I'm going to go ahead and jump out this board. Hopefully we're cold enough right now because we're at 48 degrees and we were running a little below freezing. So if I go to my little test pins right up here at the top, this one and this one, our pins underneath there are our timers, and this one I would prefer to be set to 30 minutes. It's on 60 right now, so I would prefer to have this yellow jumper pin moved over to the T1. So we've got a T1 which is 30, we have a T2 which is 60, and a T3 which is 90. And being in East Tennessee, we can never go longer than an hour. Our real efficient units will make it an hour and be okay to defrost just once an hour, but older units like this that are not that efficient, they really need to defrost every 30 minutes and keep that coil clean. There's no sense in letting it build up a bunch of ice and losing all that efficiency. You're just defeating the purpose. So up here on these jumper pins, I'm going to short this with my screwdriver, and hopefully our sensor is closed and we'll go into defrost. Sometimes you have to hold it for a little while. If not, we will have to jump out our sensor. And it's looking like we might have to do that. So let me go ahead and pause this. Let me get a jumper out and we'll be right back. Alright guys, we're back. So we've got that big blue wire nut off of there. I've got my jumper from there over to the blue wire here on the board. So we're now simulating that our sensor is closed. And the other thing I've done, I've hooked up my meter leads on that top set of normally closed contacts that's got the fan going. So right now, since it's closed, with your meter set to voltage, you should have 0. Alright? When this thing goes into defrost and energizes the coil on that relay and those contacts open up, we're going to get a voltage reading right there, because we're going to make a circuit. Alright, so let's go back and test this thing with our screwdrivers. There we go. Alright, so she went right into defrost. We're now energized on this coil down here. We de-energized the reversing valve. You hear it shifting. The fan turned off. And you see we now have a voltage reading there because those contacts are now open. And then if we also come over here to the blue and purple, Now that that's closed, we should have no reading there. I've got 24 on that blue wire that I'm hooked up to, and if I just go to ground here, well, let's go to a common over here. So right there is 24 volts. So I know I have 24 volts on that blue wire. And now if I go over here to the purple, we will have 0, because now those contacts are closed across there. And you see that we do have 0. But if we reverse that and we keep our lead on the purple wire and come back over here to common, we can verify that that 24 volts is passing through. It is going through that purple wire back to the heater inside, and our electric heat is now engaged. Alright, so we're going to stay in defrost as long as I have that jumper on there, but as soon as I pull this off, we should probably kick right out. And there we go. Alright, so now we have de-energized the coil. Now we're right back in heat mode. So now we're normally closed for the reversing valve. We're normally closed on the fan again, so it's back on. And now the set of contacts for the electric heat have opened back up. So now if I take a voltage reading there, that we're open, and go from the blue to the purple, go across that, see, now we've got a voltage reading there because we are open again. Alright, so maybe that will help some of you newer guys out on this older style of defrost where you're using a board and a relay in conjunction. A few manufacturers use that. Lennox also used that, but instead of a brown relay, they used a clear ice cube relay, what we call an ice cube relay. And it's just accomplishing the same thing. You've got normally open sets of contacts and normally closed sets of contacts. But of course, Lennox is energizing AC with the call to O, the reversing valve and cooling, like everybody else does. But then Rheem does it in the heat mode. So we always have to keep that in mind whenever we're working on these old Rheem units. And if we look up in there, our sensor is mounted up there to the right of the capacitor on that larger diameter copper tubing up there. So we're mounted right up in that corner. Those are never any fun to replace. Got to pull some cabinet apart to do that. So anyway guys, I'm going to put my wire nut back on here, cover up our commons, and this unit is going to be okay. We know that the defrost is working properly. We're now set to 30 minutes right here on this pin, so that's going to work a little better for this older unit. And you know, it is what it is. We'll just do the best we can with what we got out here on this thing. The refrigerant level checked okay. It's not leaking, so you know, just keep it going. But you know, I'm not gonna come through here with a fine-tooth comb and a vacuum cleaner and clean this thing up and shine it like a freaking Lamborghini or a Cadillac or something, because it's just not gonna get maintained. So anyway guys, if you have any questions for me, leave that in the comments down there below. I appreciate you watching my video. Leave me the big old thumbs up. Subscribe to the channel if you haven't already. And guys, I will catch you next time.